So in this example, we have another equation with a couple of trig functions in it. This time it's two sine functions that are kind of mixed together in the same equation. We have the sine squared of x is equal to the sine of x. And again, the domain is going to go from 0 to 2 pi. Now, there are two approaches that it might make sense to use here. And so to kind of understand what those two approaches are and why one is good and one is risky, I want us to consider a simpler example first. So before we get to this equation, let's pause this one and let's think about this simpler equation. X squared is equal to x. You might be able to solve that just mentally in your head, but let's go through the steps anyway and just kind of see what can result if we're not careful. So we're going to solve this in two different ways. The first way is I'm just going to divide both sides of this equation by x, and then the other way I'm just going to move everything over to one side and try to factor it. So let's just take a look and see what happens. Follow the logic with me here. So if we divide both sides by x, that's going to get this statement right here. So x squared over x is equal to x over x. A bunch of stuff cancels out, and we get x equals 1. Great. Sounds good. Now, let's take a look. And that makes sense too, right? X equals 1, 1 squared equals 1. So that makes sense. Let's check it out now and see what happens if we subtract and factor. And you may be ahead of me on this one. So x squared is equal to x. Let's just subtract x from both sides. And so we get this statement. X squared minus x equals 0. And then if we factor that, we get this. X times x minus 1 is equal to 0. And we can see pretty clearly at this point that there are two solutions to this equation, x equals 0 or x equals 1. So I'm just going to hide some stuff here before we proceed. Should have had this set up before I started my lesson here. There we go. Okay, so the trouble though is that on this side I got two answers. On this side I only got one. Well, let's test them out, right? So one is the same, so that makes sense, all right? But let's go back and test the 0. 0 squared does equal 0. So this turns out to be a valid solution. So why didn't we find it? Like, this is a true answer. Why didn't we find it when we did this method? Well, the reason is because if x equals 0 is a solution, what did I do on this first step here? I divided by 0. So that's not allowed. And so when that sort of thing happens, if you're canceling out a variable like that, what can happen is that you can lose solutions. So you have to be really careful when you're dealing with some of these equations. You don't want to lose solutions. So instead of dividing, what we want to do when we're dealing with trigonometric equations, don't use division to cancel terms out from both sides of the equation. Instead, what you want to do is subtract and factor. Now, that the caveat to that is if you're creating a tangent function, like on the last example, we did the sine of x over, we divided by the cosine to create a tangent function, that's okay. But in this case, what I'm doing is wanting to avoid is dividing both sides by a value where it cancels out in both places. So that's what I want to avoid is this kind of situation where I jump from here, canceling out on both sides and get to an answer here. 'Cause I can lose some answers there. So we use that approach on this example. What I'm going to do is subtract the sine of x from both sides. That's going to give me sine squared x minus sine x equals 0, and then factor the sine of x out of both sides. That gives me this statement here. The sine of x times the sine of x minus 1 is equal to 0. We can split that apart into two different equations. So the sine of x equals 0, or the sine of x equals positive 1. If we scroll down here just a bit, if we add the 1 to both sides, right? So that means the y-coordinate on the unit circle is either 0 or 1. So there are 3 points on my unit circle where that is the case. 2 points, the angles 0, pi, and 2 pi for the y-coordinate being 0, and then the y-coordinate being 1 is only located at pi over 2. So those would be my solutions. Of course, in this particular problem, we would need the positive or negative that I have missing there. So just watch out for that. So make sure you have the plus or minus on the 2 pi given the domain that I had for that restriction. So those would be your solutions.